Hello, we're Team 10, and this is our interim presentation on the analysis and redesign of electric water kettle. The teammates consist of Matthew, Brooke, Sam, Anya, Miles, and Ahmed. So here's a basic description of our product. It's an electric water kettle that is a covered container that is used to heat up and boil liquid, usually water, for consumption. Our production volume target is approximately 500,000 per year. Our primary customers are avid coffee and tea drinkers that will use the electric kettle to heat up water for their coffee and or tea. And the secondary customers are small business owners that will use the electric kettle to heat up water to make specialty drinks with little operating cost. Here is an exploded cat view of our product, and we have 13 parts. The first part is the base plate, then we have the power circuit board subassembly, base plate cover, plastic body cover, heating elements, electronic subassembly, plastic handle, on and off button, steel kettle body, steel spout, glass lid sealing ring, glass lid, plastic lid, and a plastic lid handle.
Here is our fast diagram, which details the functions that the kettle performs. As can be seen, our primary functional branch is to provide boiling water.
The first assembly sequence starts off with the base plate, then putting the power circuit board subassembly, then putting on the base plate cover, then putting on the steel kettle body subassembly, which starts off with the steel kettle body, then putting on the steel spout, then putting on the plastic handle subassembly, heating element subassembly, then putting on the plastic body cover. Then we finally add in the glass lid subassembly, which starts with the glass lid, then the glass lid sealing ring, the plastic lid, and then the plastic lid handle. The second assembly sequence starts off with the steel kettle body, then putting on the steel spout, then the plastic handle subassembly, then the heating element subassembly, the plastic body cover, and then we insert in the base plate subassembly, which starts with the base plate, power circuit board subassembly, the base plate cover. Then we put on the glass lid subassembly, which starts with the glass lid sealing ring, plastic lid, and the plastic lid handle. Comparing the two sequences together, sequence 2 ranks higher since it's easier to fasten and join, easier to test the subassemblies, and easier to assemble in parallel.
A function component mapping matrix was created to illustrate which electric kettle product functions were realized by which components. The current state electric kettle demonstrates a somewhat integral architecture, as a couple functions are realized by a relatively large number of components. These functions include contain water and contain heat. However, there are some functions realized by one or a relatively small number of components in a more modular manner, which identifies components that help form a core product platform. Product variants will be derived from this core product platform.
Here we have our bill of materials, or BOM. This includes the number of parts, their respective names, quantities, materials, as well as manufacturing processes, assembly processes, material cost, assembly cost, and tooling cost per part, as well as total unit cost per part. Our estimated total cost for the whole assembly is $35.46.
A quad chart was created using the function component mapping matrix and the bill of materials. The quad chart aids in identifying components of the electric kettle that should be redesigned using DfM methods and tools. Components identified as having high manufacturing cost and high functional importance include the steel kettle body, the steel spout, and the glass lid. Components listed in the low manufacturing cost and low functional importance quadrant, or the high manufacturing cost and low functional importance quadrant, should be considered for elimination. Lastly, components in the low manufacturing cost and high functional importance quadrant should be kept as is.
Looking at our function differentiation table, many of our functions are the same for both customer groups. However, the one function that does differ a little bit is containing water, as someone working in a coffee shop making many drinks at once is likely going to need to contain and heat up a bigger volume of water than someone just making a warm drink at home. Translating this into our component commonality table, many of our parts are platforms rather than modules because the functions are the same across both customer groups. However, as I mentioned, the volume can be different. So our steel kettle body that holds the water is a module rather than a platform because the size of this could change.
Here is the component design for the primary product variant on the left and the secondary product variant on the right. The kettle body was chosen to be increased in height from the original 7.087 inches to 9.087 inches. The next slide here is the computer-aided design for the common interfaces between the platform components and each module component. Some common interface parts include the baseplate and baseplate cover, the entire top cover, the handle, the heating electronics and elements, and the on-off button.
The original assembly sequence starts off with the steel kettle body, which has two variants, so you can see there's no shared assembly line. So for the modified assembly sequence, we assemble the steel kettle body after the base plate cover so we can have 3 shared assembly lines. The steel kettle body can't be shifted down further since it will be infeasible to assemble the parts.